Hello folks, and how are you all doing? So in today's video, we will make a simple particle life simulator like this one. So here we have three kinds of particles as you can see. We have some green particles, some blue and some red. So these green particles or balls, these are like our plants. They cannot move and they will regenerate after some time automatically. Now the blue particles are like herbivores and these animals will feed on these plants and after eating one plant they will also reproduce and increase their number. And the red ones are like carnivores. They will only eat herbivores and carnivores need to eat three herbivores to reproduce. And if these animals or particles whatever you may call, if they don't eat for a while, if they don't come in contact with each other for a while, they will die. And this is a very interesting ecosystem. As we can see, we initially started with some particles, and all the numbers are changing. So we have a good number of green particles, and blue and red particles have kind of stabilized. And as we can see, blue is going up and down. So for green. So when green comes down, blue also comes down, and red increases. But with less number of blues, so even red start dying because red cannot eat each other. So yeah, this is a very interesting one. And we will also have some controls that you can of course add later, uh, using which we can basically check with different parameters. We can click on the start and it will restart 1 second. Now going forward, we will also try to add few more things like vision and some kind of a neural network if possible, like if the particles can learn from their mistakes. Maybe some other organisms also apart from these very simple particles, maybe moving plants or something else, maybe different kind of terrains, like this is all sand, something like sand. And there can be water, there can be grass, many things we can think on that. But yeah, let's see how we can build this very simple ecosystem first and then we can take it from there. So let's go back to our VS Code and let's start with our code. So I am at my VS Code and I would like to keep things simple and sweet for now. So I will just create a boilerplate in my index.html file and let me change the name to um, particle life simulator, something like this for now. And in the body, I will just create a canvas and then I have to attach one JavaScript file also. So let me create a script.js file and here I will simply attach this file. All the controls and other things we will do later. For now, let's start with our code. Now in my script.js, I will start with creating a canvas and this will be document.querySelector and we will select our canvas. Then we have to create our context. So ctx canvas.getContext and this will be 2D. One more thing I will do is here um, I will create styles and I will give some styles to the canvas. So here I will write canvas and let me give the background color as wheat. Let me open in live server. Let's see what we have. And we have some canvas here. I think this is good for now. So, but we need some more size. So what we will do is we will change the width and height of canvas. So canvas dot width. This will be the inner width and canvas dot height. This will be let me keep it square. So I will do inner height and let me keep it little bit smaller and let me put it down equals to canvas dot height, something like this. So let's see. We have a large enough canvas. Now what we need to do is we will have to create a class called particle. In this particle class, we will specify everything that we have related to the particles, and then let's assume the class is empty for now. And then what we have to do is create an animate function. Inside the animate function, we will do request animation frame, and then we will call our animate function. This is something that will help us animating the particles. So let's get started with our particle, and then we will see how we can animate different stuff over here. So in the constructor, I will have some variables. First of all, the position. So this is something that we will take as an input. We will also take the y as input, and let's say the color. Color is also specifying what kind of particle it is, plant, herbivore, or carnivore. So this dot y equals to y. Then this dot color equals to the color. And then we also need some velocity in the x-axis and the y-axis. And this is what? This will be a random value. I will assume between -3 and +3, or -2 and +2, whatever. But only when the particle color is red or blue. So what I will write is color equals to, if it is green, in that case, the value will be 0. Otherwise, the value will be math.random times 6. This will create a value between 0 and 6, and this in between -3 and +3, and same for the Vy. Then we will have some radius. I will initialize it to 5. Ideally, these things can be inputs also, like we had those bars to change these values. But yeah, for now, we can start with this. Taking it as input is fairly simple. Anyway, so we will also give a life of 500 that will decrease if the particles don't get food. And then for the red particles, we also need to give a count of how much food they are consuming. So food consumed, um, the initial value will be 0. Now, how can we draw the particles? So here we will pass the ctx, and here we will draw the particles like how we draw circles. So ctx dot begin path, and in the end we will also close it, close path. And in between, we have done this many times. We will do ctx dot arc, this dot x, this dot y, then this dot radius, and then the start angle is 0 and the end angle is 360, which is also maths dot phi times 2. And then the ctx dot fill style will be the particle color. So this is nothing but the this dot color, and then ctx dot fill. Now let's draw some particles and let's see what we get. So how can we draw the particles? We have the draw function, but we need some particles, and then only we can call this. So let me create a particles array. Initially, this is empty, but using for loops, we will insert particles into it. So let I equals to 0, then I is less than something that we will write, and I plus plus. And inside, we have to pass the values x, y, and color. So x will be a random value, and what is the value of x? This is math.random times my canvas dot width, and for y this will be the canvas dot height. This will initialize value in between the width and in between the height, so creating a good enough coordinate. And then we will do a particles dot push, and here new particle, and we have to pass the values x, y, and let's say green for now. Now, I is less than what? To do this, we will create another variable. I will name it life count. So how many particles do we have? It's like the board that was counting the particles, right? So this will be an object, and this object will have green count. Let's initialize it to 50. Later we can change. Then blue count. Let's also keep it 50. And lastly, the red count. Let's keep it 5. We cannot have too many carnivores initially. So, because we are creating green particles, what we will do here is life count dot green count. And similarly, we will create 2 more for loops. So here, the life count dot, this will be blue count, and The color will also be blue. Remaining things will stay as it is, and here it will be red count. Red count. But that's not all. We have to now draw the particles. So how can we draw? Very simple. Inside the animate function, we have to loop through all the particles and then draw one by one. So here, what we will do is we will create another for loop. And here, let's take a particle I equals to 0 and I is less than. Let's keep particles dot length because we are pushing everything to the particle. So this is the total number of particles. And then I plus plus. And here, what we will do is simply, um, let's take a particle P. And this P is not parse in. This is the particles from the particles array. This is the ith index. And we can simply do P dot draw CTX. And let's see, we get something or not. So yeah, so we got a lot of static particles, but the particles look weird a little bit. It doesn't look circles. Uh, let's do one thing. Let's increase it to 50. Not 50, let's increase it to 10. And let's try to understand what is happening. So these spheres look a little bit weird, and the reason is very simple. The reason is that our particles are actually inside the animate function. So the problem here is this that these are repeatedly getting drawn, and because of this reason, it looks a little bit weird. Um, but yeah, these particles will generally be moving, so we don't really have to worry about that much. For now, we can keep it as it is. We have to create an update function for the particles also because we need to keep track of where the particles are moving. So here we will do an update ctx, and here first of all we will draw, and then we have to update our x and y values. So this dot x will be plus equals to this dot vx, and then this dot y will be plus equals to this dot vy, and then um, we also have to decrease our life. So if the particles are not getting any food, ideally their life should also be decreasing. um, yeah, so let me put it like this. If the particle is not a plant, so plants generally don't die because plants are regrowing automatically. They will create food from sunlight, and so they will not die. Others will die. So if the color is not equals to green, then their life will decrease by minus 1, minus equals to 1. Sometimes I really think that plants are having the best time of their life. We have laws not to cut trees, and they don't have to worry about food and worry about any bills or anything like that. Anyway, so that's one thing. And the second thing that we want to apply is that when some particle is reaching the end of the screen, they should pop up in the other side of the screen. So no particle should go outside in that sense. Anyway, we will do that. But first of all, instead of the draw, let me do a update. And let's see what do we get. So the particles are painting, not moving in that sense. And the reason is because uh, we have to clear the canvas every time they're moving. So this is the reason this is happening. So what we can do here is we are doing the update, and after the update we will also clear the canvas, and this is something that we can do at the top only. So ctx dot clear rect starting from 0 0, ending at canvas dot width and canvas dot height. This will resolve the issue. So yeah, particles are moving great, and the circles are also fixed, I believe. So yeah, so the particles are vanishing when they're reaching the end of the screen. This is not something that we want. We want them to pop out at the other side. So here in the update, we will make the world round, you can say. So round world. So how can we do that? So if this dot x is greater than equal to my canvas dot width, what we want is this dot x should be equals to 0. That's not all. And if it is going out from the other side, if this dot x is let's say less than 0, then what we want is this dot x should be equals to canvas dot width. And the same for the y also. Acha, this is not else, this is else if. And similarly, if this dot y is greater than equal to or greater than whichever, both are fine, I believe, canvas dot height, then this dot y should be equal to 0. Else if this dot y is less than 0, then this dot y should be equals to the canvas dot height. Canvas dot height. So now the particles will move better. So yeah. So the particles are vanishing here and they will come from on the other side, and yeah. But now the particles are not doing anything. I mean, they are interacting, but they are not eating or they are not dying. Nothing like that is happening. So this is something that we have to do next. And also the particles are big. We can reduce the radius to be 5. I believe it's too much. Okay. I don't know if these are very small or not, but yeah, you can adjust. I think for this video, we can keep it 10 for now. Yeah. Okay. So, how can we do these things? So inside my animate function, as we are looping through the particles, we have to check if particles are interacting or not. So we will need a nested for loop. And because of that, we want to do one more thing. Instead of I will make it I1 and I1, because inside there will be another loop. It's like the nested loop. So for let I2 equals to, and I will do one more thing. I will iterate through the particles from the end. So I will do particles dot length -1, and I will loop it till it is greater than equals to 0, and I will do I2 minus minus. Now why I will do this? I will let you know soon. If I1 equals to I2, first of all, we have to continue. We don't want to check anything because it's the same particle. Now I will create another P2, and this will be particles I2. Now the same thing needs to be applied for the I1 also. It will be starting from the particles dot length, and I1 should be greater than equals to 0, and I1 will decrease. Then P1 is the I1th index of the particles, and then we are updating. Yeah, and one more thing we can keep here is the life. The life check is very straightforward. So if p1.life is less than 0, then what happens? Then we will remove this one. So particles dot splice, and we want to remove the I1th index, and we want to remove 1. Yeah. Now the reason we are keeping we are looping from the end to the beginning is that if let's say the ith particle, which is let's say the second particle, is removed, so the index 3 becomes the index 2. And because there will be many particles dying, eating each other, these things are happening. Um, there is a possibility uh, uh, of misbehavior. Not misbehavior, like it may happen that we want to deal with the second particle, but the second particle is already dead, and it is imposing the behavior of the second particle on the third particle. So this kind of issues may arise. So wrong behavior, you can say. So because of this reason we may face, we are doing it like this. See, anyway, so particle, we are removing the particles, and yeah, one more thing we need to do, and that is we also have to decrease the count. So we have 50, 55. So this is something also that we need to take care of. So if p1 dot color equals to green, what we need to do is life count dot green green count. We need to decrease that one. Similarly for the blue and red. So else if p1 dot color If this is equals to blue, we will remove the blue and not remove, like decrement the blue. So blue count minus minus, and else let's keep it else if only p1 dot color, because later we may have more particles also as today. You can also use a switch case instead of this one, but yeah, both are fine. Life count dot rate count minus minus, and yeah. So our life is kind of sorted, and if none of this is there, then we simply continue. Although that case is not here, but yeah, anyway, in case. Now we have particle P1 and particle P2. Now we need to check the interactions between particles. Now to do this thing, there is something that we need to take care of, and that is we need to find a distance. And to get this distance, I want to write a function distance between two particles, and I want to take P1 and P2. Now we don't have this function. This is something that we will write now. So function distance between two particles, and what is the input? The input is our P1 and P2. And this is a very straightforward function, something we may have done in coordinate geometry. So we will first of all take the x distance. So this is P2 dot x minus P1 dot x. Then we will take the y distance. So x, not x, x dist. Anyway, whichever is fine. P2 dot y minus P1 dot y. Then we will take the square distance. So this is the sum of squares of this. So something like math dot pow x dist comma 2. So this is basically x distance into x distance for simplicity. Math dot pow y dist comma 2. This is the square distance, but the original distance is the square root of this one. So math dot sqrt of the square distance. And then we will return the distance. So this is the distance between these two particles. And when we have the distance, what do we want? So we want to check the interactions between them. So if the distance is, let's say, okay, so we are returning distance. Um, yeah, so this will be a number, and uh, this number, if this number is less than my radius, let's say, I want to do things. So if dist is less than, let's say, my p1 dot radius or p2 dot radius, in this case both are same. So in this case, I want to check what are the different colors. So if p1 dot color equals to let's say blue, uh, and my p2 dot color equals to green, in this case I want a certain kind of interaction. And there is another case, else if this is if p1 dot color equals to blue, and p2 dot color equals to red, I want another kind of interaction. There are no other interactions here as such. This is a very simple simulator in that sense. So if this is the case, the first case, so what do we want to do? We want to remove the green. So particles dot splice the index I2, and we want to remove one only. And then we will also update the life count dot green count minus minus, and the blue will reproduce. So life count dot blue count plus plus, and p1 dot life p1 dot life will be reset to 500 because it just ate some food. And p1 dot food consume, it is zero anyway. It will be zero. It was not zero, it was one. Then it got reset to zero. Later, if we want to change the rules that the herbivores must eat two plants to reproduce, so we can change the food consumed, etc., here. So this is what will happen here. Oh, yeah, one very important thing we just forgot, and that is we also need to add the blue particle. So particles dot push a new particle, and this new particle will originate at the same location of p1. So p1 dot x comma p2 dot y. p1.y, and the color will be blue because it will regenerate of its own kind, of course. I mean, reproduce, whatever. Anyway, so very simple, kind of simple. Let's see. We see any interactions or not. Okay, I believe there are some errors. Let's try to find that out. So let's remove all of these things. So cannot read properties of undefined reading update. So in line number 79 and 126, we have some issues. 79 p1.update, it doesn't understand what is an update. And then 126, we have another issue. Another issue is this animate is having some issues. So let's try to find out what is the issue. Mm, okay, and it's a very silly issue actually. In our I1, we are actually starting from the particles.length, but ideally we should be starting at length.-1 because arrays are from 0 to n minus 1, not 0 to n, because it's programming. We all know it's not math. And now, if we go back to our canvas, we can see some interaction. And as we can see, green particles are actually vanishing. For example, it's gone. And after some time, all the blue particles will also vanish. Red is already gone because they are not getting any food. And we are gone. We are in a totally empty planet. So it's working, but we can definitely make it better by adding other kinds of interactions also. Most important thing is we should have a way for the plants to regenerate because plants are all gone and so green is also gone. So how can we regenerate plants? Very simple. We will create a set interval, and what we will make sure is the plants will regenerate after every 100 milliseconds. And how to regenerate? We have to create x maths.random times canvas.width. Then y is also very similar. So it should be canvas.height, although both width and height are same. And then we will do a particles.push, new particle, x, y, and green. And we will also increase the green count. So life count dot green count plus plus. And now I believe we will have more greens. So let's see. Yes, so greens are coming, but still all the greens are getting overrun by the blues because there are like too many blues and the blues are not coming down. Now blues will also stay and I believe greens will also stay. We have kind of reached an equilibrium. Greens will stay because greens will regenerate. And so blue will also stay, but the reds are all gone because we have to add the rules for our reds also. So let's see, what can we do for the carnivores? They should also live, right? So first of all, if this is the case, we want to remove the blue. So the blue is the I1 and we want to remove one. And then life count for the blue will come down by 1. Now for the P2, that is for the red, after eating one blue, I want to restart the life at 500. So its stomach will be full, but still not there to reproduce. And the food consumed, whereas food consumed, it should also increase by 1. And when the food consumed will reach 3, in that case, I want to again restart the food consumed to 0 and I want to reproduce. So particles dot push. The new red will come at the old location of the red. So new particle. So p2 dot x, p2 dot y, and the color is red. And then life count dot red count plus plus. And in the end, we will break. Like if something is there, we will break. Uh, I mean, yeah. Anyway, either this or this will happen. Really doesn't matter. I don't think we need to break. But yeah, now I think we have our ecosystem more or less ready. So, something is happening with the red. Red is behaving little bit weird. Now why is that? Okay, it has eaten all the greens, and now the reds will also die soon. Let me add the break here. Hmm. I think the behavior is better now. Hmm. Okay, I believe we have reached some kind of equilibrium. We have mm, reds, blues, and greens. Now the reds will start dying because they don't have much food. Now the blues are increasing their numbers. Yeah. So I believe what was happening is kind of like, so when we generally do a break, what we do, we get out of the loop, not the if or something like that. So we are getting out of this loop, right? So when we are getting out of this loop, um, now why we are doing this? Because let's say this particle is a blue. That is what we are checking. And with respect to this particle, we are checking if the I2 is either green or red. Now, if the I2 is a red, we are basically removing the I1, that is the blue. So there is no need to go through this loop again. Why? Because now all the indices have changed. Let's say the fifth particle is a blue. Now, when the fifth particle is removed, the sixth will become the fifth. And if we don't do a break here, that means um, it will, as I've said, that if we don't look from the end to the beginning, some issues will come because of index overlapping. So same for this one. So this is one example of something weird that may happen. But there is no need to do the break here because here the blue is not vanishing. Yeah. So we have kind of formed a simple ecosystem. Now another thing we can add is a counter, like um, how many blues, how many greens, and their numbers basically. But yeah, this is something that we will do along with the controls in the next video. It's a simple thing for now. What we will do here is we will simply do a logout and we will see how the numbers are changing. So here we will simply log life count and let's see. So we have green is decreasing, blue is increasing, and red is also increasing little by little. Now red will increase fast. Green is very low. So now the we have more red than blue. Now blue is on the verge of extinction, I believe. So can they survive? Yeah, they can survive because when blue is low, the green will go up. So this is kind of a balancing act. Now we have a lot of blues once again, and now again we have a balance. So I think the reds have an upper hand, but none of these particles will go extinct, and that is, I believe, oh, I think they're gone. I think they're gone. Yeah, blue is zero. So now very soon red will also become zero. Yeah, now we only have plants. Not good. I think if we simply have a smaller radius, this thing will be resolved. So let's make it 5. And let's again see what do we have. So we have lot of blues and greens are very low and reds are also very low because there is less interaction because of the lower radius. But very soon I believe there will be a lot of reds. Yeah, so reds are increasing and the greens are still low. Actually, plants should be maximum, even more than herbivores. Now, blue count is low. I believe we can actually regenerate plants faster. So where we were doing the set interval, let's make it 50. I think this will be much, much better. Because anyway, plants will never get extinct, but the count of blue depends on the count of green. So now we have a lot of blues very soon. And as a result, there will be a lot of reds soon. Yeah. And the plants are somewhere around 50. Now blue and so we have a lot of reds, lot more reds and blues. And let's see if blues get extinct or we still have some chance. I believe blues will never get extinct because now we have lot of plants and the blues will also reproduce faster. Now, yeah, it's kind of a warfare going on. So this is how we all evolved, frankly speaking. Millions and millions of years ago, the plants and animals and everybody was fighting like this, and that is how we became. But yeah, we can definitely make this ecosystem better. Now, as we can see, a lot of greens, so a lot of blues once again. So it's kind of like a cycle is going on. So yeah, folks, so that's it for this video. I believe we have a lot more things to play around here. We will add the controls, we will add the table, and I believe we can also add a chart, some a chart that will record the cycles. We have chart.js in JavaScript using which we can create charts easily. And let's see what kind of interesting things we get. So last time we did a neural network, and we will also gradually see how we can use the neural networks to train this kind of behaviors, and we'll see a lot of interesting things ahead. So that's it for this, folks, and we'll see you soon.